Asynchronous I/O or asynchronous input-output in Python refers to a programming paradigm that allows you to write concurrent and non-blocking code that can handle multiple I/O operations efficiently. With asynchronous I/O, you can perform I/O operations such as reading from or writing to a file, making network requests, or interacting with databases without blocking the execution of other code. Python provides a built-in module called Async.io that supports asynchronous programming. It introduces two keywords, async and await, which allow you to define and work with asynchronous code. The async keyword is used to define a coroutine function. Coroutine function is a special type of function that can be paused and resumed during its execution. Coroutines enable you to write code that can perform other tasks while waiting for input-output operations to complete. The await keyword is used inside a coroutine function to pause its execution until an asynchronous operation completes. When an await statement is encountered, the coroutine relinquishes control back to the event loop, allowing other coroutines or tasks to run. Once the awaited operation is finished, the coroutine resumes its execution. By leveraging async and await, you can write non-blocking code that takes advantage of the event loop provided by Async.io. The event loop schedules and manages the execution of coroutines, ensuring that they run concurrently and efficiently. It handles the coordination of I/O operations, enabling your program to perform multiple tasks simultaneously. Asynchronous I/O is particularly useful when dealing with tasks that involve waiting for I/O operations to complete, such as network requests, database queries, or reading writing files. By using asynchronous I/O, you can also improve the performance and responsiveness of your Python applications, especially in scenarios where you need to handle multiple I/O input-output bound tasks concurrently. Overall, asynchronous I/O in Python, powered by async and await, provides a powerful mechanism for writing efficient and responsive code that can handle I/O operations concurrently without blocking the execution of other code. Now, I would like to give you an example to demonstrate the use of asynchronous I/O in Python using async.io module. So let's create a code that will help you understand the use of async.io in Python. I'm going to create a code and then I will explain how the code actually works. So I'm going to open a new file to uh, write the code and to save it as well. All right. Now I'm going to import the module first, and the module we're using is async.io. Then I'm going to create a function my coroutine where I'm going to print coroutine started await async IO and um, okay, I need to Yes, make it sleep for some time. So maybe, for 1 second, right? And this is usually done when we are working with a time consuming task. So we are trying to simulate a time consuming task. Now here, coroutine resumed, and we are going to return coroutine completed. Okay. Mm, yes, that would be it. And you would notice that after this return statement, when I go to next line, it automatically takes me out of this function because this is the end of this function because we are returning a value. Then we can create main function, async main, def main, coroutine. So coroutine, okay, I need to use list comprehension here. So my coroutine for I in range 3, or instead of I can also use maybe an underscore. I'll use I in range 3. Results await async async io dot gather star coroutines, right? So we'll have to do some packing, unpacking. Then I'm gonna print results. Then I'm gonna come out of it. I'm gonna have event underscore loop async io dot get underscore event. Um, Let me think a little. Okay, so if I try to just write it like that, I think let me come up with a code that will help you understand better. So if I try to just write it like event loop and okay, yes, I think that will do. Um, I'll have to, yes. So yeah, I think we can do that. So, and don't worry, I'm going to explain the code underscore loop dot run underscore until underscore complete main, right? So, sync dot sleep my coroutine. Okay. Um, let me run this one. Let me save it first. Example program, right? And then I'm gonna run it. Okay. It shows why. I think I wrote somewhere. Um, all right. So in this example, we define a coroutine function called my underscore coroutine, and it simply prints some message, right? It's printing a message coroutine started. It waits for 1 second. So this statement is used to make it wait. So we're using the keyword await and then async io.sleep, and we are using the statement inside the coroutine, right? So it waits for 1 second using this statement await async io.sleep 1, and then it prints another message before completing and returning a result, right? The main function is also defined as a coroutine function, right? So coroutine function, I already explained what it is. If you remember the slide, when you're using async, so def is used to define a new function, and if you're using async keyword, it becomes a coroutine. So the main function here is also defined as a coroutine function. Within it, we create a list of coroutines by calling my underscore coroutine 3 times, right? Um, if you can see, uh, I'm running it 3 times. So range 3, right? We then use async io dot gather in the next statement to schedule the execution of these coroutines concurrently, right? And finally, we create an event loop using async io dot get event get underscore event underscore loop and run the main coroutine using event loop dot run until complete. So we are running the main um, coroutine. This allows the event loop to manage the execution of the coroutines and wait for them to complete, right? And once you run this program, when you run this code, you will see the coroutines executed concurrently and the messages will appear with a delay of 1 second between each, right? So when you run this one, right, when you run this code, these are printed concurrently with delay. So let me run it again. Okay, so the output looks something like this, right? And uh, this example actually illustrates or demonstrates how async and await keywords allow you to write non-blocking code and perform input-output operations concurrently, resulting in more efficient and responsive programs. And so in this example, I'm going to explain one more time um, because I know it can be difficult to understand for some. So in this example, the code demonstrates the usage of coroutines and an event loop in the context of asynchronous programming with async IO. Let me walk you through the definitions one more time and also explain how we are using them, using different elements of asynchronous programming here. If I talk about coroutine, a coroutine is a special type of function that can be paused, it can be resumed during the execution. So it allows other tasks to run while it's waiting for an input output operation to complete. And in this example, my underscore coroutine is an asynchronous function defined with async keyword and it prints the message, it waits for 1 second using await async io.sleep 1 and then it prints another message. So it represents a simulated time consuming task. If I talk about event loop, the event loop is an essential component of the async IO module and it is responsible for managing the execution of coroutines and coordinating input output operations. And in this example, the event loop is created using async IO dot um, get where was the event loop? Yes. So async IO dot get underscore event underscore loop, right? And then it is assigned to the variable event underscore loop, right? So this is the variable and this is the event loop. And if I have to talk about the flow of the code, you see the main coroutine function is defined with async keyword. And inside this main, a list of coroutines is created. So coroutines, this is a list. If you remember, right, we use brackets to create a list, right? So inside main, we are creating a list of coroutines by calling my underscore coroutine function 3 times, right? And we are using a list comprehension. So if you don't know what list comprehension is, um, check the link in the description, or you can also check the I button, right? You can check that video I created on list comprehension. So we are using list comprehension here to populate this list. Okay. And then async io dot gather, this one, right? This function is used to um, schedule and execute the coroutines concurrently. And it takes the coroutines list as arguments, right? Because this is the list, coroutines is a list, right? And async io dot gather, this function is taking this list as an argument. And because there are many elements in the list, so we are using this star operator, right? And so this function um, collects the results of coroutines and returns a list of results in the order of the coroutines. And this results variable, so we have this results variable, right? This variable awaits the completion of the coroutines through await async dot gather star coroutines. Okay, and to run the asynchronous code, the event loop is initiated using um, this statement event underscore loop dot run underscore until underscore complete main. This method executes the main coroutine until it is complete and waits for all scheduled tasks to finish. And in a nutshell, in summary, the coroutine my underscore coroutine, this represents a time consuming task that can be paused and resumed, allowing other tasks to run concurrently. The event loop is responsible for managing the execution of coroutines, coordinating output operations, and ensuring the completion of tasks scheduled within it. Right? And this part here, star coroutines, this is making use of asterisk, right? This star operator, it's making use of this star operator to unpack the list of coroutines into separate arguments. Okay, when the async io dot gather function is called, it expects separate arguments representing the coroutines that need to be executed concurrently. The star coroutines syntax allows us to pass the list of coroutines as separate arguments to this gather function. Okay, and if you want a more simplified um, example, let me just to show you the usage of star operator with the list of coroutines. um, Async io, so first I will import it, a sync def my underscore coroutine, right? And here you can implement the coroutine, right? And then async def main, so here coroutines, you can say my underscore coroutine for I in range 3, right? Await async io dot gather star coroutines, right? So this statement here, I really hope you're able to understand. Um, right? So this statement here, it unpacks coroutines, right? And then I can just say asyncio dot run main, right? So star is used um, for and in this example, the coroutines list is created using a list comprehension again to generate multiple instances of the my underscore coroutine. And when async io dot gather is called, this star coroutines is used to unpack the list of coroutines, and then they are passed as separate arguments to gather function, right? And we are using this star operator, uh, and since we are doing that, each coroutine from the coroutines list, from this list, because we are using star operator, um, every coroutine from this list will be treated as an individual argument, right? So gather function can actually execute them concurrently. And the star operator, it is commonly used in Python to unpack iterables such as lists or tuples or sets, and it unpacks them into separate elements when calling a function that expects individual arguments. And in this case, it allows gather function to work with the coroutines individually and schedule their concurrent execution, right? So this was a little bit about the use of asynchronous programming in Python. I hope you understood. And main idea is to understand, the use of um, async IO module, and it works with coroutines, it works with event loop. Then we have two important keywords, await and async, right? So I hope this video lecture was helpful. If you still have any doubt, you can always ask in the comments below this video. And I will see you in the next video lecture. Till then, take care.